Chapter 41, General Strategy for Factoring. Here is a flowchart, essentially. So you start with a polynomial. You first look for the greatest common factor. The greatest common factor is 1. You just keep on going. It is not 1. You factor out the greatest common factor and then look at the remaining polynomial. If it is a binomial, then is it a difference of two squares? If so, factor is x plus 1 times x minus 1, and I guess maybe you're done with that part. Is it not a difference of two squares? Is it the sum of two squares? Yes, you're done. You cannot factor that. If it's not a sum or difference of squares, is it a sum or difference of cubes? If yes, if you have x plus or minus y cubed, you can factor it as x plus or minus y, x squared minus or plus xy plus y squared, and you're done with that one. In general, if it is x to an odd power plus or minus y to the same odd power, you do it in the next class. We are not going to do it here. So let's backtrack. We have the binomial. We have a trinomial. Is it a trinomial? Yes. If it's a trinomial, is it x squared plus or minus 2x plus y squared, which is in the form of a perfect square, like right here, and you're done. Or is it in the form of 1 times x squared plus bx plus c, which means it's in the form of x plus an integer and x minus an integer, which you can get by inspection. Or if it is not a equals 1, you can use my special product sum method. The product AC, the sum B. Run through all the divisors or factors of the product till you get a sum that you want. The two magic numbers tell you how to split up BX. And what else? Oh, if there are more than 4 or more terms, then factor by grouping. Maybe you get pairs, maybe you get triples. It depends on the format. So this is the general strategy for factoring.